All right, today we're going to be talking about distance between 2 points and midpoints. And a midpoint is a point that's in the middle of two other points. All right, so we're going to use this as a definition right here. The distance between 2 points is the absolute value of the difference between their coordinates. So if you've got a number line, and there's 2 points on the number line, they're calling them P and O. And what they're referring to those points, point P is called x sub 1. It's a variable with a subscript of a 1, also known as point number 1. And then you've got an x sub 2, which is your second point. And this formula for the distance between those 2 points, we're going to say PO is equal to the absolute value of x sub 2 minus x sub 1. Or you can do the absolute value of x sub 1 minus x sub 2. And for these purposes, absolute value means the positive version of a number. All right? The absolute value of positive 3 is equal to positive 3. The absolute value of negative 3 is equal to positive 3. All right? Absolute value is technically how far a number is from 0 on the number line. All right? On the number line, if you've got 0 right here and you've got positive 3, well, positive 3 is 3 units away from 0. All right? But negative 3 is also 3 units away from 0. When you're talking about distance and how far something is from something else, that measurement is always going to be a positive number. So when you find the difference of these two coordinates, the absolute value of the difference, and difference means to subtract, the absolute value of the difference is going to be the distance between the 2 points. Okay? So let's look at example 1 there on page 25. And you've got a number line with quite a few points on it now. All right, in this case, you're asked to use the number line to find BE. So you go BE. BE would be equal to the absolute value. The absolute value of B to E would be the distance from B to E would be the absolute value of the difference of the coordinates. So B to E would be the absolute value of -6 minus +2. All right, when you're dealing with absolute value, you finish what's inside the brackets. All right, so that would be the absolute value. -6 minus 2 would be -8. And the absolute value of -8 would be equal to +8. So from B to E on this number line would be 8 units. Down there on the bottom, they ask you to find AC. From A to C. The distance from A to C would be the absolute value of -7 minus the coordinate of point C, which is -4. And -7 minus -4, that's a keep, change. Or you can just type it in your calculator. So -7 plus 4 would be -3. So the distance from A to C would be equal to 3. If you were asked to find the distance from C to F, would be equal to the absolute value of, we're going to go point C, which is at -4, and we're going to subtract point F, which is at +5. So from C to F would be the absolute value of -4 minus 5, which is -9. So C to F would be equal to 9. Now, some of you you're good at being able to tell how far it is from one point to another point when the numbers are whole. When it gets confusing and when you need to use this formula is when the numbers or the points correspond to decimals. Okay? And then it's not so easy to do it in your head. And you need to remember the formula that the distance between 2 points is equal to the absolute value of the difference of the points. You just subtract their coordinates and you write down the positive version of that number. Clear? All right. Any questions on finding the distance between 2 points on a number line? All right, turn the page. On page 26, there's a key concept. Distance formula in the coordinate plane. All right. So now, distance formula, the last distance formula you did was on a number line. Now you need the distance formula on a coordinate plane. And we're going to call it distance in the coordinate plane. Okay, so the distance between 2 points. Let's get a little picture right here. We're going to make this quadrant 1 of a coordinate plane. This is your x-axis and this is your y-axis. Here's your origin. And we're going to put a point. We're going to say that we got a point right here and a segment. And we're going to call this first point P and the second point Q. And let's say that P is at, we're going to make this 1, 1. P is at 1, 1. And we're going to say that Q is at 7 and 8. So Q is at 7, 8. All right, so the distance formula, here's your distance formula. Distance is equal to square root of, we're going to say x sub 2 minus x sub 1 squared plus y sub 2 minus y sub 1 squared. Now here's where those numbers come from. Your x sub 2 and your x sub 1, those are the x values at your 2 points. Okay? Your y sub 2 and your y sub 1 are your y values at both points. And here's what I like you to do when you're finding the distance in the coordinate plane. Whether you're given the picture on a coordinate plane or you're just given the 2 points with their coordinates, not on the coordinate plane, just label the coordinates. At this point P, we're going to call this x sub 1 and y sub 1. There's your x sub 1, which is 1, and your y sub 1 is also 1. Then at the other point, we're going to call it the second point. So this is your x sub 2 and your y sub 2. If you will take the time to label the points, you'll eliminate making errors when you put the values into the formula. All right? So here's what your next step would look like. Once you've labeled the points, you can go back to your distance formula and you just substitute. All right? Where there's an x sub 2 in the formula, your x sub 2 is equal to 7. So you take 7 minus your x sub 1 value, which in this case is 1. So you got 7 minus 1. You close your parentheses and you square it. You're going to add it to. You got a left parenthesis. And then you've got your y sub 2, which is 8, minus your y sub 1, which is 1. And you're going to square that value. So your next step is to just start your computing. So you got 7 minus 1, which is 6. And you got 6 squared plus 8 minus 1 is 7 squared. So you're getting closer. You got the square root of 36 plus 49. And in your calculator, take 36 and add it to 49, which is the square root of 85. Okay? And now we're going to approximate that. So in your calculator, 2 buttons above the 9, there's a button that looks like this, the square root of x. All right? And since this 85 is sitting in your calculator, you can just push this button, and it's going to give you a value with a bunch of decimals. And it's like 9.219 5445 more. Keeps going, fills up your whole screen. Okay? But we're going to round everything to wherever the book asks you to round to. All right? And in this case, it looks like they're going to the nearest tenth. So how many of you have this calculator I asked you to get? 2 of you? 3 of you? You got it out right now? You want to have it out right now. Because you want to be doing all these calculations that we're doing in class with me so that you can practice doing them. So that you're putting everything in the calculator the way you're supposed to. And so that I can show you how to use your calculator. So right now, turn your calculator on and push 85 and hit your square root of x button, which is 2 above the 9. You should be with me with the 9.219544457 on your screen. And then what you can do is you can push the green button, which says second. And you can push the period button down the bottom below the 2. That's second fix. And then you push the number 1. Second fix 1 tells the calculator to round it to 1 decimal place. So when you push second fix 1, the number on your screen should have just changed to 9.2. All right? And you use your second fix button whenever the question has an answer that's a decimal. If they ask you to round to the nearest 100, you can push second fix 2. That'll round it 2 decimal places. And you can have your calculator do all your rounding for you. All right, so does anybody got a question on that problem? Finding the distance between 2 points on the coordinate plane, being able to find the square root of a number, and then being able to round that number to the nearest tenth. Everybody's all right with that? No questions on finding the distance on the coordinate plane or finding the distance on a number line. All right, turn the page. Here's your assignment for today. On page 30. You're doing problems 1 through 10. 1 through 10. All right. Some of those are distance on the number line. Some of those are distance on the coordinate plane. All right. So problems 1 through 10. And actually, no, you're not doing 1 through 10. I'm sorry. You're just doing 1 through 8. Problems 1 through 8. And let's see, let's say you make sure that you are check all odd answers.